Hey, how are you? It's me, Miss Wesley. Hope you're ready to start talking some trig. You can join me on page 15 of the Trig Packet, where I want to start with a little bit of review for starters, just getting on the same page about exact values of trig functions. Now, so far, we've gotten pretty familiar with the exact values of the sine, cosine, and tangent of these three special angles, 30 degrees, 45 degrees, and 60 degrees. And we've learned that there's a pattern with those exact values. I claim that filling out this convenient table, just the sine and the cosine rows, actually unlocks the answers for the values of all six trig functions of this angle. So how does that work? Well, sine of 30, these are all over 2, fractions over 2. The sines in their numerators count up, so it's square root of 1, square root of 2, square root of 3 for those numerators. And the cosines do the opposite. Cosine of 30 is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2, and then 60 is going to be a half. So how would this get us, say, the tangent of each one of those angles? Well, we've talked about how you can get tangent by taking y over x, or in this quotient trig identity, tangent, you can trust that it'll always equal the sine over the cosine. So I've got those two things here. I can make a big complex fraction, put this guy over that guy, have the 2's cancel, and we showed the past couple of days, you're going to get square root of 3 over 3 for your exact value. Tangent of 30, you just get used to the value. You don't need a calculator. What could be easier? Tangent of 45 degrees. You're just dividing the same fraction by itself. So anything over itself gives you 1 as an exact value. And putting the sine over the cosine for 60 degrees and having the 2's cancel, you'll get square root of 3. I'm not going to do it this second, but I could make more rows with the cosecant. I'll flip the values of the sine, right? Secant is going to be the reciprocal of all the cosines, and tangent would be the reciprocal, or cotangent would be the reciprocal of those tangent values. So that's good to know for starters. But I mentioned something about how this doesn't just limit us to angles in quadrant 1. Knowing these answers for 30 degrees can give us the 6 trig functions exactly for 210 degrees. And that's because of something called a reference angle. We've talked about this too. In the last lesson, we talked about reference angles. Let me just draw 210 being the acute angle. If this whole thing is 210 degrees, what's the little acute angle, right? How much past 180 are you to get to 210? You have a 30-degree reference angle hugging the x-axis there. And this diagram shows it even better than I could draw it. Here's a certain right triangle that's constructed, right, with the x, y, and r with 30 degrees past 180. You'd be making the exact same size right triangle in quadrant 1 with a 30-degree reference angle. These the absolute value of these dimensions would be the same for this quadrant 1 triangle. So numerically, I'm getting the same numbers, absolute values, as the 6 values I would get for the sine, cosine, and tangent, etc. of 30 degrees. But I do have to think about whether or not I want to be positive or negative for each of these values. In quadrant 3, I'm thinking only tangent and cotangent stay positive. Okay, so that's what we covered already. It's time to practice some more with this, and we're getting dangerously close to one of my favorite topics, which is going to be called the unit circle. So that'll happen on the next page. But let's see what we can do. Can we pick it up after number 12? Let's pick it up with 13 and see if we can just use some of those same skills that we've been doing in the previous lessons. So 240. I've got some steps above, and step 1 says, well, can you get a sense of where 240 falls and what its reference angle would be? Because I'm hoping it's going to be a value from this table. I'm hoping it's going to be a value like 30, 45, or 60, where I know an exact value for its trig function. Where's 240? So 240 is also down in quadrant 3, right? Initial to terminal side, 240 degrees. And you ask yourself that important question, what is the reference angle, right? What's the acute angle between the terminal side and the x-axis? Take 180, right? So 240 minus 180, that leaves you 60 degrees left over. You've gone 60 degrees past 180 to get to this terminal side. So use that. The cosine of 240 is going to be the same number as the cosine of 60, but I'm not guaranteeing it would have the same sign. Well, let's find that out. AST, only tangent and cotangent are positive here. Let's put a negative answer for 13. All right, so now here goes. Negative cosine of 60, we got to think cosine of 60 would be a half. So leave that. We can check it with the table. That would be negative a half for that answer. Okay, secant of negative 120. It's kind of curious that this one just follows directly after that one, because negative 120, I'm pretty sure falls in the same spot as 240. Start at 0, right? You're traveling clockwise 120 degrees this way. You ask yourself that question, oh, I'm in quadrant 3 again, the T quadrant, and what's my reference angle? Well, if you've gone 120, right, how much more would you need to get to a full 180 to the other side? That is also a reference angle of 60 degrees, 180 minus 120. So this thing is the same as the secant of 60 degrees, but like we said before, we're in a quadrant where secant would be negative. So we'll put a negative sign in front of it. It is the reciprocal of a half, right? So we'll say negative the number 2, reciprocal of cosine. 675, okay, so I see a number where it would be helpful to get something coterminal that's lower. Off the bat, before I even draw anything, let me subtract 360 from this and get cotangent of 315. Let's figure out where that falls and get a reference angle. So 315 is going to be almost to 360, not quite, all the way over into quadrant 4 because you're past 270, I know that. What is your reference angle? I'll put a little theta prime in here for the reference angle. Well, here you can use a 360. We haven't gone quite all the way to 360. 360 minus 315 gives me my reference angle. Luckily, it's one we're comfortable with, 45 degrees. So cotangent of 315 is the same as the cotangent of 45 degrees with a possible negative sign that needs to go out front. So let's think ASTC. Is this the C we're talking about? So we keep it positive? Right? All is all of them. S is sine, T is tangent, and C is cosine, and its reciprocal are positive. So cosine and secant would be positive there. Cotangent needs to be negative. So I got to think the tangent of 45 degrees from the table we know is 1. And if you flip 1, you still have 1 back, right? The cotangent is also 1, so we'll say negative 1. Don't let something like 16 scare you off. It's like 3 problems in 1, and you've got that squared trig notation that we've seen once or twice, but it's good to keep on practicing with. Let's rewrite all 3 of these to make them a little bit easier to understand. Start with the cosine of 120, and let's handle this like we would have any of the other problems on the sheet. So think of where 120 falls. 120 is going to be over here in quadrant 2. We're kind of used to this reference angle because we saw it in 13 and 14. It takes you 60 degrees to get back to 180. So for starters, with the cosine of 120, let's think of it as the same as the negative cosine of 60. We'll have it equal to the negative cosine of 60. Do we agree with it being negative too? Because you don't always have to switch the sign, but here I think it's a good idea. AS, cosine needs to be negative if you're in that quadrant. All right, for the next part, I just want to change the notation. Plus 2, think of what you're squaring. It's a little tricky to see that 2 on the inside there. What it means is you're taking the sine of 60 and you're squaring that value. And here, likewise, you're taking the tangent of 30 degrees and you're going to square that value. Okay, so I think everything's set up to use exact values. First, think cosine of 60 degrees. Think exact value. Cosine of 60 degrees we said is a half, so negative a half. Plus 2 times the sine of 60 degrees squared. So think to the sine of 60 degrees. Square root of 3 over 2 is your exact value, minus the tangent of 30 degrees squared. So tangent of 30 degrees is actually square root of 3 over 3, but to get it, you put 1/2 over the square root of 3 over 2. I'm going to write it in its non-rationalized form. I'm going to write it as 1 over the square root of 3, so I have lower numbers and a little less work to do. You'll see how these 2 values are going to be pretty convenient to square and simplify. All right, now time to simplify. So negative a half, that looks good. Plus 2, now just square this part. You square what's next to it. So square the square root of 3, you get 3. Square the 2 on the bottom, and you'll get a 4. Minus, I want to square this top and bottom. We'll have 1 over 3. So this is negative a half. We can cancel these. So plus 3/2 minus 1/3. And 1.5 minus a half gives you 1. Minus 1/3 should be an exact value of 2/3. It's funny because you could actually type this whole entire thing carefully into the calculator to check, and it'll give you a decimal. I love exact values. I have not been reaching to the calculator for anything on this page because I want the exact value of the trig function. Now, because I can't resist, I want to take a sneak peek at the next page with, I'm going to have to leave you in suspense because we'll get more into it in the lessons to come. The unit circle is coming. I just want you to know that it's coming. And what we're going to do is we're going to work in degrees today and tomorrow, and then we'll switch over into this other unit of measure for angles that's pretty convenient called radians. So don't think the unit circle is a topic that we're going to pick up and then leave. We're going to stick with it because I do love this unit circle. Now, do you remember seeing it before? Do you remember why we called this the unit circle, this little picture that's at the top right corner of page 16? Because the radius of the circle is a unit. And you remember we used this for getting exact trig function values of quadrantal angles. Like I could wow you at a party and I could say, I know the cosine of 270 degrees, because I would look at this little diagram, go down to 270. The cosine is always going to be the x value on the unit circle. The sine is going to be the y. Do you remember why that happened? Like, why am I just ignoring r? Well, in a little bit, when we get down to taking notes on this page and we talk about trig function values on the unit circle, remember, sine still equals y over r. I'm not changing that. From the very first day we learned about the trig functions, we use that definition. But in the unit circle, do you remember the r is kind of trivial because the radius is 1 around the entire circle? The sine is going to be the y value. The cosine on the unit circle is going to be the x value, that's for sure. And the tangent is still going to be y over x. And I'll leave some of this stuff. We'll also put cosecant, secant, and cotangent on this diagram too, but I want to leave a little bit of it for the lessons to come. What I want to show you is that not only can we label, so can we do a little bit of this first? Can you label for me, just for practice, the quadrantal angles around this unit circle? So label me 0 degrees, let's say 90 degrees, 180, and 270. It would be good to just have those on there. And then you're back around to 360 again. No need to really show it because we already have 0 degrees there, but I guess just to be thorough about it. What we're going to talk about in the coming days is we can also label angle measures at these special angles in quadrant 1. So a 30-degree angle I'm going to put here, right? If you go 15 more degrees, you've reached 45 degrees. And if you go 15 more degrees than that, you reach 60. What we'll start doing, remember values that you were given on the last page. Do you remember seeing 120 on a bunch of examples? It was no mistake that I chose 120 for those examples because I wanted there to be a reference angle of 60 degrees. Do you remember seeing, I don't know if we saw 135 if I add 15 to that, but that's going to be an important one. And we definitely saw 150, I'm pretty sure we saw that has a reference angle of 30. Just like I've been telling you, the sine, cosine, and tangent of 30 is closely tied to maybe like the sine, cosine, and tangent of 150 because that has a 30-degree reference angle, or the sine, cosine, and tangent of 210. The same thing happens visually on the unit circle. So if I were to draw a little triangle here, drop a perpendicular, it would have the same dimensions as this triangle here that has the 150-degree angle with a 30-degree reference angle. The sines, cosines, and tangents of these two angles are definitely going to be linked. All right, I've already said too much. We're going to save this topic for the next lesson and keep on practicing with your table and your exact values. I will talk to you soon.